Today, we're kicking off with someone who absolutely changed the game in AI, Professor Fei-Fei Li. Ever heard her name pop up in the world of computer vision?
I sure have. She's often called the mastermind behind ImageNet. What's wild is, she spotted the flaws in existing datasets and decided to build something way more ambitious, a kind of gold standard for testing AI algorithms.
Exactly. Before ImageNet, the field was kind of stuck. Fei-Fei Li realized we needed huge, diverse, well-labeled collections of images to really push AI's ability to understand visuals.
And her vision didn't just spark a new dataset, it basically became the backbone for all the progress we've seen in computer vision over the last decade.
Speaking of inspiration, did you know WordNet played a huge role in this? It's not just some dusty old dictionary, it actually shaped how ImageNet organizes information.
Yeah, WordNet is fascinating. It's like a living map of words, with hierarchies showing how things relate. So, a chair's wheels are part of a chair, and the chair fits in a classroom. It's all nested. That structure is what helped language models. And Fei-Fei Li used it for images too.
Totally. Tapping into that hierarchy let ImageNet sort images into thousands of categories with real-world relationships, sort of like giving AI a way to see context, not just shapes.
That context is powerful. It's why models trained on ImageNet can tell the difference between, say, a husky and a wolf. It's not just labels, it's about meaning.
But honestly, creating ImageNet wasn't just about collecting pictures. The real mountain to climb was labeling them. Think millions and millions of unique images.
Exactly. And unlike words, where there are dictionaries and reference materials, images are a whole different beast. No shortcuts, each one had to be carefully tagged, and there just weren't enough grad students in the world for that job.
It's kind of mind-blowing. Even a whole university of students couldn't have finished it. So, what do you do when the problem's too big for one group to handle?
You get creative, for sure. That's where crowdsourcing entered the picture in a big way.
Let's dig into that twist, Amazon Mechanical Turk. If you've ever wanted to make a few bucks online doing tiny jobs, this is your place.
It's basically a global gig economy for microtasks. People from anywhere can hop on, label a batch of images, and get paid. Fei-Fei Li brilliantly plugged into that system to solve the labeling crisis.
It's funny, isn't it? Sometimes the best innovation is connecting two things that seem unrelated, like AI research and internet gig work.
That pairing sped up ImageNet's growth like crazy. Suddenly, what seemed totally impossible became doable, and it's a great reminder that tech breakthroughs often come from looking outside your own field for solutions.
All that crowdsourced labeling wasn't just busy work. It's the foundation for training powerful AI models. Without labeled data, neural networks can't really learn what's what in an image.
Right. AI needs that ground truth. Imagine trying to learn a new language without ever hearing anyone speak it. That's what unlabeled data is like for machine learning. So, Mechanical Turk and similar platforms still play a big role in today's AI pipelines.
And it's not just about images. These human intelligence tasks, or HITs, cover everything from labeling to checking if two products are the same to testing new algorithms.
It's amazing how something as simple as labeling can have such a huge impact on advancing technology. The more data and the better the labels, the smarter our AIs get.
Now, after building ImageNet, Li and her collaborators didn't just leave it sitting there. They launched the ImageNet Large-Scale Visual Recognition Challenge, or ILS-VRC.
That annual competition was a genius move. Suddenly, teams from all over the world were racing to build the best image recognition algorithms, pushing each other and the field forward at breakneck speed.
And the progress was dramatic. In 2010, even the best AIs were making errors almost 30% of the time. But by just a few years later, they were matching, then even surpassing human performance. That's wild.
Honestly, it shows how much a little healthy rivalry can motivate innovation. Everyone wanted to break that 5% error barrier, and eventually they did.
That reminds me, 2012 was a real turning point, thanks to AlexNet. This deep neural network blew the competition away and grabbed the world's attention.
AlexNet was a game changer. It achieved 85% accuracy on this massive dataset, which wasn't just a win, it reignited interest in neural networks. Suddenly, everyone wanted in on deep learning.
And that's when the tech giants started pouring in resources and talent. It's no exaggeration to say AlexNet's win fueled a deep learning gold rush.
What's cool is, AlexNet's architecture using convolutional layers set the trend for everything that followed. It proved that, with the right data and hardware, machines could see in ways we didn't think possible before.
Once the results spoke for themselves, the money followed. Venture capitalists and angel investors started betting big on AI startups, and universities became hotbeds for new ideas.
You're right. And it's this mix academic curiosity plus industry funding that kept the momentum going. When you've got working prototypes, like AlexNet, investors get excited and scaling up becomes a reality.
It's kind of a perfect storm: brilliant researchers, open datasets, new algorithms, and now real resources to build out these dreams.
Which just goes to show, breakthrough technology needs both the right minds and the right money behind it to really change the world.
After those breakthroughs, the industry dove in head first. Tech giants snapped up deep learning experts, and companies started rolling out AI-powered products everywhere.
And those competitions weren't just for bragging rights, they started affecting real business outcomes. Winning an ImageNet challenge could boost a company's stock price or land them major contracts.
It's pretty wild that an academic contest could have ripple effects in the actual economy. Shows just how much faith investors had in this new wave of AI.
But when there's that much pressure and money on the line, sometimes things go sideways, which leads us right into the world of ethical dilemmas.
Let's talk about ethics for a sec. Do you remember hearing about that cheating scandal in one of the ImageNet competitions?
Oh, I do. A major tech company manipulated their test results to look better than they were. It's a stark reminder that when you mix prestige, money, and pressure, some people might cut corners.
That scandal really highlighted just how important integrity is in AI research. If people can't trust the results, the whole field suffers.
And it's not just about getting caught. These incidents push the community to set stricter rules and focus on ethical development, especially as AI becomes a bigger part of our lives.
It also shows that progress in AI depends on more than algorithms and data. It needs a strong ethical backbone too. All this talk of accuracy raises a good question. Are AIs actually better than humans at seeing and understanding images?
Well, on benchmarks like ImageNet, AIs can technically outperform us in raw accuracy. But humans have a unique knack for subtlety and context. For instance, we're not easily fooled by small changes in an image, whereas AI might misclassify a slightly altered photo.
That's such a key point. The way humans recognize objects is deeply tied to understanding context, something AI still struggles with. Plus, some ImageNet photos are so tricky, even experts have trouble labeling them.
And it gets even tougher in real-world situations, like self-driving cars. AI might mistake a baby for a tree if it hasn't seen similar examples. That's a huge limitation right now.
That leads us to what's next, moving from just recognizing images to actually understanding them. It's one thing for a machine to say, "That's a cat," but quite another to comprehend what a cat is and why it matters in a scene.
Bridging that gap means integrating visual recognition with language and world knowledge. The goal is to build systems that not only identify objects, but interpret, reason, and interact naturally like humans do.
Exactly. It's a huge challenge, and it's why computer vision research is becoming more interdisciplinary, bringing in insights from cognitive science, linguistics, and beyond.
I love that idea. Real progress might come when different fields work together. And for students or researchers, that means there's a place for all kinds of backgrounds in this journey.
So, as we wrap up, it's clear that innovation in AI is a continuous process. Data is the new currency, and hardware like faster chips is just as crucial as clever algorithms.
That's right. The journey from early datasets, like the ones used for zip codes, all the way to AlexNet and beyond, shows that persistence and fresh ideas keep driving the field forward.
And don't forget, today's limitations are tomorrow's research questions. Keeping an open mind and supporting multidisciplinary work will help us tackle the next wave of challenges.
The future really depends on our ability to push past recognition and build systems with true comprehension. It's an exciting time, and I'm eager to see where the next breakthroughs come from.
Same here. If there's one lesson from Fei-Fei Li and the whole ImageNet story, it's that connecting ideas sometimes in unexpected ways can lead to revolutions in technology.